The Dice Mooncake game is a Chinese moon festival game where you roll dice within a China ball to see what kind of prize you get. You roll 6 dice, the normal kind of dice, and depending on the result, there are a range from the first prize to the 6th prize you can receive. There is a probability in which you can get certain results, and I will be trying to find the probability in which you get the first prize. In particular, there are 6 conditions in which you can receive first prize. 1. You can roll all 4s. 2. You can roll all 1s. 3. You can roll all of a kind. 4. You can roll 5 4s. 5. You can roll 5 of a kind. And 6. You can roll 4 4s. To find the probability, we need to find the ratio between the amount of cases that match the condition for the first prize against the total amount of conditions. Now, when comparing your results to the conditions, there is only 2 possibilities. Either you match the number you wish to receive, or you don't. They can be considered as successes or failures. The only time in which a condition is met is when every dice roll is considered to be a success. Therefore, we can calculate for the probability in which all the conditions are met in each condition for the first prize. Every dice roll has the same probability of being either successful or a failure. This means that the probability in which a dice roll is successful is 1 over 6. The more times you roll a dice, the probability of every roll being successful multiplies itself by another 1 over 6. Using this, we can conclude that the probability in which everything is successful is 1 over 6 to the power of how many dice rolls you wish to be successful. In our case, this is 6. However, sometimes that is not totally the case. There could be conditions in which failing to get a certain roll is a part of the conditions as listed in the price. For example, getting 4 4s. Therefore, in reality, the equation for probability of matching a condition is not as simple as it may seem on the surface. We need to times the probability of failure, which happens to be 1, or the probability of anything happening, subtracted by the probability of success. And remember, in some cases there are multiple failures. Therefore, it should have the power of the total dice rolls minus the amount of cases you wish to be successful. Now, you have a neat equation. But wait. There are different combinations of which dice roll is successful or failures. The one that fails to match the number you want could be either the first or the last dice roll, or any in the range. Because of this, the total amount of cases of the condition met must be calculated via combination. There are a total of 6 dice rolls, and we will let the number of rolls I wish to be successful be equal to r. Now you get the final equation for binomial probability. It happens to be that the Dice Mooncake game's conditions for winning can have its own probability calculated via the equation because every case has the same probability of either matching the number you want or not. To find the probability in which you get first prize, you simply take the sum of all the probabilities for the 6 cases for first prize. Now, remember, for every case, we simply replace the variables that were in the equation to what we need to match that case. Remember, there are 6 cases. Well, they can be rounded up to be 3, as getting the probability of all of one kind includes the previous 2 cases, and the same applies to getting 5 of a kind. Now, one thing to note is that for case 1 and case 2, there's actually 6 different cases in which that applies, which means that from number 1 to 6, this case applies. This means when we calculate for the probability, these 2 cases must be multiplied by 6 because you can get 1, 2, 3, 4, 5, 6. As for case number 3, you only have to times it by 1 because it's only getting 4 4s, so only the number 4 applies. Finally, we times it by 100% and we get the final number, about 1.2%. Thank you for tuning in, and that is my video for getting the probability of getting first prize within the Dice Mooncake game.